Have you been thinking about automation for your shop, but maybe you're just not really sure where to start? I know in my case, that's where I'm at. So we're here at Okuma today to talk to some people to figure out what the best practices and most frequently encountered challenges are when it comes to automation. But before you do, make sure you like, subscribe, and turn on notifications below to make sure you never miss a video. Let's get into it. So to help answer some questions about automation, especially as someone who has not been in it, we're joined by Wade. Wade, thank you very much for joining us today.
Thanks for being here.
Wade is the head of automation for the Okuma factory.
Automation, you nailed it.
I got there. Now, obviously as a guy who works a lot with automation, I take it this is not a situation that is new to you. Someone coming in who maybe doesn't have as much knowledge in here. And I mean, when we're looking around this place, you guys have some absolutely amazing automation solutions, but for someone who doesn't have any of it, it can feel a bit intimidating at times. What do you say to shops out there in a predicament like mine who are looking for a good way to start getting into automation, you know, get their feet wet, but maybe are still a little apprehensive?
Sure. The first thing, I'm gonna go way back, is start with the process. And is the process that you have capable of being automated? Meaning, do you have complete control of all the variables? Because if you're going to automate something, you have to control the variables. So do you have a part that isn't making burden-ness chips, stringers, things of that nature? Do you have chip contamination issues where if you take an operator that's taking a part off a fixture, does he have to clean and wipe the surface before he can put the next part on? You know, those are considerations that you got to think through before putting a robot, regardless of the color or the style of, or a gantry loader, any kind of automation. Can your process be repetitive and capable of being automated without eyes on target? Because you're relying on the process to be ready. And then from there, I would step into pre-engineered type solutions. The system we have in our background here, that's a pre-engineered robot cell that has all the guarding, all the safety factors built into it. It's a drawer cell that will accommodate a wide range of parts. And that's a simple way to get started because that system can hit the ground and there's really no integration needed. We would come in, spend a couple of days ringing out the interface to the machine, the control, but the programming, we basically pre-teach the load positions in and out. And then after that, the programming is a conversational program. So you don't need a guy that is comfortable driving a robot pendant and teaching points. He just has to be able to look at the screen and conversely tell what you want it to do. So it's very simple. So that would be a starting point. We're seeing a lot of things in the collaborative robot space. I think the technology that people are investing into the collaborative space has made the programming a lot simpler.
Right.
Whether you're talking a UR, Omron, a Fanuc CRX, there's a lot of different people in that space now with the collaborative robots. And they've all got drag and drop icon type programming. So they're putting a lot into that to make it easier for the DIY type people that want to say, hey, I want to take this on and integrate it myself. So those are things that you can look at, and those are great starting points to kind of crawl, walk, run into where you're wanting to go.
Exactly, it's a good spot to get your feet wet a little bit.
Yeah.
Now, to kind of touch on that, obviously you're a guy who has seen a lot of installations, a lot of applications. Through that, what would you say when people are making these kind of decisions or putting automation on the floor? What are some of the biggest mistakes or errors that you've seen time and time again that people are making when they're approaching these?
Certainly. Two main things that come to mind, and one, I'm going to back up to what I said earlier, the process.
Right.
They overlook the process. Little things like if you're putting a part on an ID mandrel, for an example, if your operator has to kind of shake it and get that feel to get it to slide on, the robot's gonna, not that it can't do it, but it's gonna have problems in that arena.
It doesn't feel and know when it's properly seen. I mean, I'm sure you can program it that way, but as an entry-level thing, that's just introducing an error.
Absolutely. Chip control is a big one.
Really? That's a huge factor, eh?
Yes, huge factor. And in areas that you might not be thinking about. So the machine behind you, that's a horizontal machining center. You can see the rear exit chip conveyor. If you walk behind that machine and it's not clean, you're going to have problems. And it's not so much from a robot problem, it's a process problem. In that, so an example that we see sometimes, especially on horizontals, you're running production volume, you're running 3 shifts a day, we'll see areas where coolant starts foaming and you float chips. If you're machining high-speed aluminum, for an example, and you've got those fines in the coolant. So first shift, the guy comes in and he checks all the coolant levels, the concentration, gets everything right, gets the coolant right. And then second shift, through the heat generated in the machining process and evaporation, your water starts to evaporate, your coolant concentration is getting richer, and all of a sudden it starts foaming, all these fines start foaming, and they spill over into the clean tank. That gets picked up by the through spindle coolant going through your spindle. Eventually you're going to shut that cell down, and you're not going to be happy that you've got an automated cell not making production. Now that's not a robot problem.
No.
That's a process problem. That's having the right controls over, do you have the right chip conveyor? Are you filtering out the material that you need to? Do you have automation or processes in place to keep tabs on your weigh oil, your spindle lubrication, your coolant concentration, things of that nature? So those are things that I think a lot of times shops often overlook. The other thing I think about is the software processing, just making sure your parts, your upstream processes are ready for automation, and the post-processing from gauging and making sure you have quality controls in place. Automation will let you make a lot of parts.
They may be bad.
That's right.
But you'll make a lot of them.
You can make really good parts, you can make really bad parts, but you can make a lot of them. So you want processes in place, you want to have gauging that is communicating either via the gauge to the control or whatever process. There's a couple different processes you can do, but you want that gauge and those parts in a closed loop environment where as the parts are coming off, you have an inspection plan to monitor and have some SPC controls in place. So if something goes awry, you're stopping it or getting ahead of it before something bad happens.
Before 5,000 of them come off the wrong way.
Yeah.
I mean, a lot of it sounds like, I guess I'm almost just reiterating what you said, that the automation almost isn't the difficult part. It's the unattended factor. Whether that comes down to something like maintenance or the inspection, it's the fact that people plan to run them unattended, but then don't plan for everything else that involves not having a person at that machine frequently.
Right. Yep.
Now, when it comes to, as a guy who's seen so many of these, and again, you've seen the problems, are there any situations where you would say genuinely someone should not be looking to automate a certain job? Obviously process control, if that's an issue, but is there any kind of job where you look at it and you say, honestly, it's better to do it with less automation or without automation? And the answer may be no. Maybe there should be automation in most things, but have you come across a scenario like that before?
So I'll give you my opinion, the gospel according to Wade. Now, other people may look at this and say it differently, but to me, when you're doing super low lot sizes, like if you're only doing 1 or 2 parts, and you're not going to repeat that job, that's a manual operation. I get asked this a lot. Can you take a 5-axis geometry type part and go from drawing to finished part with no operator intervention? In theory, there's enough software controls and 3D virtual monitors or Vericut type systems, things like that.
Feature-based milling.
There's enough electronics and digital knowledge that in theory, yes, you can do that. In reality, I've never seen anybody successfully do that.
I've never seen people attempt it. You've seen people attempt it.
I've seen people attempt it. We've been asked to quote it for certain companies for special applications and things. But all the times I bring machines, I watch all of our AEs run, and you still need to prove out that first part. There's gotchas that sneak in that you just haven't seen, regardless of all the tools that's available in the market space today. I just don't think all the technology is brought together. I'm sure there's going to be some CAM company out there that's going to roast me saying, we do that all the time. In reality, I work for an OEM. We have some of the best AEs in the world, and we still prove things out.
You haven't actually seen that just first off, go away type scenario.
The most amazing shop that I've seen from an automation perspective, he runs 400 millimeter size horizontals. Jeez. The entire plant, that's all he runs. He has standardized the entire shop. He has one platform. All of his machines, I think there was 18 machines. They are all calibrated, meaning perpendicularity, squareness, the pitch yaw roll of the axis, everything, all of his machines are calibrated to 3 microns of one another.
Jeez.
He has one machine dedicated just to process development. So when he takes on new work, he puts it in the machine. He has a skilled machinist, skilled operator, setup guy that proves everything out, makes sure his tool link's right, all that. And then that goes into the system. That goes into the automation cell, and it can be called up at any time and go on any of his machines. That is the most high-tech manufacturing, and I've been to a lot of facilities. That by far, he had it dialed in and nailed, but he still had somebody manually doing that first part.
And it sounds funny though, the most technologically advanced place you've been in, it sounds like the biggest factor with it was standardization.
Standardization, 100%.
It's not he had the biggest machine or he had the most sophisticated machine, and I'm sure they were great.
Right.
It's the fact they were all exactly the same.
Yep.
And that's more difficult than you think if you haven't done that before.
And it takes discipline, because, and that's one of the questions I asked him is, what of this was the hardest thing for you to do and maintain? And he said it's discipline, because if it's a 400 millimeter size cube that'll fit on a 400 millimeter size horizontal, he will beat anybody in the world globally. He has his process, so people know if it's going to his shop, don't even quote against him, because he's going to beat you on it. But he has to have discipline to not run down the rabbit holes of, hey, here's a really cool part that's an 800 millimeter. I could buy one machine and be, that disrupts his entire standardization process. So he found his niche, he's got it, he's got his processes dialed in, and he's probably the best in the world in that space.
And automated it to boot.
Yes.
So literally, not only is it standardized, he can just, I'm sure like one of these systems here, call up a pallet, away it goes, and
right. So he doesn't care who he's competing with. Is he competing against Wade's pretty good machine shop next door, or is he competing with a guy, you know, across the pond in some other country? Doesn't matter to him. He's got his process dialed in.
What industry is that?
He does job shop work.
Oh, it's
so
job shop stuff.
He does a lot. Primarily, I would say targeted aerospace. You know, every job shop kind of has their niche that they're tied into. So this gentleman's a lot in the aerospace world.
But that's a perfect example of when one-offy, onesie-twosie stuff actually is benefiting from automation. It may not be benefiting from automated running, but having everything automated in the background to be able to pallet change, to be able to have standardized tools, automate all that, is extremely useful.
It is.
Now, if people want to find out more about automation and about Okuma solutions specifically, where can they go?
Go to okuma.com, you can go to our website, and then all of our social media pages. We're on Instagram, YouTube. We've got a lot of really good content on YouTube. We're growing that part of our marketing base, if you will. So those are always good channels to go to.
And of course, they can come see you here, right here in North Carolina.
Absolutely, anytime, we welcome you.
Thank you very much, Wade.
Hey, thank you, appreciate it.